All right, everybody, welcome to Math with Grace. Today we're going to be going through Algebra 2, Book 9, Lessons 6 through 10. Lesson 6 begins on page 17, and it's titled The Tangent Function. It says here that the tangent ratio is undefined at places where the value of the function approaches infinity. So, as you can see by this drawing, that's quite a bit different than the sine and the cosine that we've done, right? Sine went like this, cosine went like that, okay? Tangent kind of comes up from the bottom, crosses, and then crosses, kind of switches over, and then goes up high. So infinity low, crosses over, infinity high, okay? Always low to high. But the process of figuring these out is pretty much the same. This little chart here, just like with all the other charts, is important to know. Although when we're graphing these, really just one section will be enough. The period here for this one is pi long, okay? And you might be thinking, well, that's kind of weird, but if you look at here, right, we have the top and we have a bottom coming in, right? And so that's how they determined this. So when we're graphing these, really what I'm concerned with is what's going to be between the two asymptotes, the 2 points where it goes into infinity. I want to see one kind of full cycle, because the period, if we take one period, it breaks the cycle in half, and I'd rather just see one full cycle. So let's take a look at the information here. So it's on the graph. This is shown by the vertical asymptote. So here's my vertical asymptotes here, right? How it approaches infinity. That's what they're talking about. That's the vertical asymptotes. Approaching an asymptote from the left, the function values approaches a positive infinity. Approaching from the right, it's a negative infinity, okay? This is called a discontinuous function, where our sine and our cosine functions were continuous. They just flowed. This is called discontinuous, right? And it says here that the function is undefined at the values of 3 pi over 2, 5 pi over 2, and so on. On your graph here, this says 5 pi over 4, but it should say 5, or it says 5 pi over 3, I believe. It should say 5 pi over 2, okay? And how you calculate that, and remember, this is just the f of theta equals tangent of theta, which is basic one. But it is the value is the multiple of pi, and so I wrote that like this, a constant times pi plus pi over 2. That's what greater than pi over 2 means. So at every multiple of pi plus pi over 2, you have a break here, right? So here was the first one, 0 pi's, right? Plus pi over 2, so that's the first asymptote. And then you have 1 pi plus pi over 2 would give you 3 pi's over 2. That's the next one. Then you would have 2 pi's plus pi over 2, which would give you 5 pi over 2, and so on and so forth, continued forever and ever. Amen, right? Even though this is a discontinuous function, it still goes on and on forever. Amen. In both directions, just like the sine and the cosine wave, okay? It says the basic tangent function is periodic, but its pattern repeats every pi units, okay, 180 degrees. So that tells me in 2 pi, which is a 360 degree graph, right, we're going to have 2 pieces. So if I cancel it here, right, starting at 0, we have a top, a full piece, and then the bottom. So we have 2 like complete revolutions in our 2 pi space. It says the graph intercepts the x-axis at every multiple of pi. And we'll turn the page here in a minute and look at the translated versions. But it's at every multiple of pi that it's crossing the x-axis. So obviously this is 0 pi's, right? Here's 1 pi, 2 pi, 3 pi, so on and so forth, on and on forever and amen, right? And then it says here that, of course it can be translated, but a tangent function has no amplitude, okay? Due to their value approaching infinity. They don't have an amplitude. neither do they have a maximum or minimum value, okay? It said the period of a tangent function is pi over b. And remember, b is the number right here before the x. So let's turn the page and look at some of these translated ones. So all the details of sketching a graph of a tangent function are right here at the top of page 18. So let's walk through them real quick. So the first step we're going to do is draw the two most central asymptotes. Okay, most central meaning the one to the left of the y-axis, the one to the right of the y-axis. If you want to use regular scratch paper or graph paper for these, it's probably pretty doable. If you want to continue with the graph paper I provided, that's okay as well. But you are going to draw your two asymptotes by calculating pi over 2b. Remember, we have, what is it? F of theta is equal to a tangent bx, right? So it's pi over 2b. I'm not sure why they even put the a in if it can't have an a, but I suppose that's a question for another time. So pi over 2b and negative pi over 2b. So one to each side of the y-axis, right? Then you're going to determine the period of the function. The period of the function is pi over b. Now, because I've asked you to give me just one full tangent line between the two, a set of asymptotes, the period isn't really going to be expressed on here, but I do want to see it noted in your work, okay? Dividing the period by 4 allows us to determine the distance between our quarter points. Where do our quarter points fall, okay? Where is it going to be at a positive 1 and a negative 1, right? Then we find the values for the x through the quarter points, and we draw our smooth line. So let's do a couple of these examples together. Example 1. Sketch the graph of the function y equals tangent 1/2 x. Okay, part 1. Remember, find our asymptotes. So calculate the value of the two central asymptotes, which is pi over 2b. Okay, pi over 2b. And in this case, our b is a 1/2. So it's pi over 1/2 and negative pi over 1/2. So that turns into pi and negative pi, right? We simplify it down to pi and negative pi. So those are our two asymptotes that they've plotted. Perfect. Calculate the period of the function. Well, the period of the function is pi over b. So pi divided by 1/2 is 2 pi. That's our period. As you can see from this drawing, they're not including it that much. They're not going to draw that many of these tangent lines, but we need to make sure we are noting our period, okay? Dividing the period by 4, calculate the distance of the quarter points. So 2 pi divided by 4 is at pi over 2. So our quarter points here and here are going to be at pi over 2, okay? Because remember, this pi, negative pi, and this positive pi are technically quarter points. It's just that we don't actually cross them. We just approach them infinitesimally, okay? Forever and ever, amen. All right. Then it says determine the x value of the first and third quarter points, because those are the only ones we need, okay? By adding the distance between the quarter points to the value of the left asymptote. Well, we'll talk about what this means in a second, and subtracting the distance. So you're finding this is the quarter point value, right? Now to actually find the quarter point, you would take your left asymptote and add the quarter point, okay? And it just happens to be the exact same quarter point, pi over 2, right? The second is 0 because that's where we're crossing 0. And then the third is to take your right asymptote and subtract pi over 2, which gives us positive pi over 2. It's just when our quarter points are pi over 2, we're just that far away from the y-axis on either side, okay? And then it says to determine the y value of the quarter points, you evaluate the function. And to do that, we're going to use the chart on page 17. So if you look at this first one, which is the negative pi over 2, right? That's our x value. We're trying to find our y value. If you take 1/2 times a negative pi over 2, you get a negative pi over 4, okay? If you look at that chart on 17, the page before this, pi over 4 is 1, and so a negative pi over 4 is a negative 1. And so that's where we cross at -1, okay? The second point, which is this, x value of 0, well, the tangent of 0 is 0, okay? Then the third point is the tangent 1/2 of pi over 2. Well, that's again pi over 4, and pi over 4, tangent of pi over 4 is equal to 1. You'll see that on the chart on page 17. So there we have our points. We draw a smooth line in between. Don't forget the arrows that represent the fact that this goes on and on forever. Amen. Okay? Complete. Good job. Let's take a look at example 2. I know it continues up at the top, but I feel like that is overdoing it at this point. We've already finished. Okay? So let's take a look at example 2. Sketch the graph of the function y equals tangent of 3x. Now this chart has a bit of errors in it, so we just need to make a few corrections. But let's take a look. First step, as always, draw the two central asymptotes, okay? Remember, it is positive pi over 2b and negative pi over 2b, so it happens to be positive pi over 6 and negative pi over 6. So they drew those in. It's a real tight one, okay? Because the 3 in front of the x causes the function to complete its period 3 times faster, just like with the sine and the cosine, okay? This 3 here makes it a shorter period, where this 1/2 on this one made it a longer one, right? So we have our pi's over 6 as our asymptotes, okay? The period of the function is pi over 3, which is pi over b. So we know the period is pi over 3. Dividing that by 4 gives us our quarter points at pi over 12. So without doing all this plus minusing stuff, right, it leads us in the same direction, because negative pi over 6, which is this asymptote, plus pi over 12 is a negative pi over 12. Pi over 6 minus pi over 12 is pi over 12. So we don't need to keep doing the math. Once you figure out this quarter point, you're going to go pi over 12 to the right and pi over 12 to the left. That's all we have to figure out, okay? Because remember, the 0 is where this should be. This line got bumped up. It should be down here at 0. This 0 is a quarter point as well, okay? And then they have a little bit of an error right here. Yes, pi over 12 is not on the chart, but remember, we're always going to be at 1 and positive 1, okay? Negative 1 and positive 1. Those are the points that we are moving up and down, okay? And then we go on to infinity and down for forever, right? So our points that should have been plotted were negative pi over 12 comma negative 1, 0, 0, pi over 12 comma 1. There's no reason for it to be shifted up here. I think it was just a misprint when they put it in the book, okay? Which happens. That's okay. All right, let's take a look. They only gave us one problem to do for this lesson, so let's take a look at that together. All right, so we are in Algebra 2, Book 9, Lesson 6, page 19. The problem number 1 is y equals tangent 1/4 x. So the first step is to find the asymptotes. I'm just abbreviating here. And to do that, we have pi over 2b, okay? Now remember, our basic function is y equals a tangent bx, right? So this is my b. So I have pi over 2 times 1/4, right? Or 2/4, which is 1/2. Pi over 1/2 is equal to 2 pi, okay? Remember, we multiply by the reciprocal. So pi over 1/2 is equal to 2 pi. Now I went ahead and started the graph. Remember, this is going to be a plus or a minus. So at negative 2 pi, we have an asymptote, and at positive 2 pi, we have an asymptote, okay? So I'm just going to go ahead and start it. Like I said, tangents are a little bit easier to draw if you want to use regular scratch paper, but you can, of course, continue to use the graph paper that I provided. Okay, so the second step then is to determine the period of the function, which is pi over b. Okay, in this case, my b is 1/4, so pi over 1/4 is equal to 4 pi. Okay, the period, very long, right? We are not going to graph all the way to 4 pi, though it wouldn't be that much harder to add one more section. I really just want to see the tangent line between a set of asymptotes, okay? So we're just going to graph right here the most central asymptotes, okay? Now we need to determine the quarter points. So we take our period and we divide it by 4. So 4 pi divided by 4 tells me my quarter points are at pi. Now, we know that 0, 0 is a quarter point at this. We're not translating it up and down or anything yet. So I'm going to go a pi distance to the right, and this will end up being a negative pi distance to the left. Those are my quarter points right there. And then I really do have enough information to go ahead and graph this. I'm going to call this down here, just to spread it out a little bit, a -1, and we'll call, what did I go, 3 spots? 1, 2, 3, and we'll call this a +1. Okay? So at -1 pi, at negative pi, comma -1 is my first point. 0, 0. At pi, comma +1 is my second point. So I'm coming down here from infinity. I'm going to cross through here. I probably made my 1s a little too high. It doesn't give it the flow that it needs. But it's going to look a little something like that. Okay? Don't forget your arrows going on forever, amen. But that is really enough data for us to plot those points. So tangents aren't so bad to plot. Remember, first step is the asymptotes, pi over 2b. Then we find the period, pi over b. Using the period, we find the quarter points. We divide the period by 4, and that gives us our quarter points, which allows us to mark those 2 points off. Complete. All right? That's it. They only gave us one to do together. So go ahead and finish lesson 6 and meet me back here for lesson 7. Lesson 7 begins on page 21, and it's called Determining the Foci of an Ellipse. Now, we just learned to graph ellipses last week in lesson 1, book 9, lesson 1. And so now we're going to be talking about the foci of an ellipse. It says that the measures for A, B, and C in an ellipse, okay, here's what that looks like, A, B, and C, are uniquely related. So if you draw a line from a covertex to a focus, it is the same length as A and also creates a right triangle. So here is our focus, there is our covertex, they drew a line, okay? Through the Pythagorean theorem, a squared equals b squared plus c squared, the length of C can be calculated, this distance here, and if we know A and B. All right, so let's take a look at what this means based with ellipses. All right, so sketching the graph of x squared over 9 plus y squared over 4 equals 1, then determine and plot the foci, okay? Well, we know that this is a horizontal ellipse because the value under the x squared is the largest. The square root of that is 3. Square root of 9 is 3, so my A is equal to 3. The square root of 4 is 2, so my B is equal to 2. So generally speaking, they didn't actually sketch the graph for you, but we can do that right here, right? We have 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. Okay, so I'm going to be at positive 3, 0, negative 3, 0, 0, negative 2, and 0, positive 2. Now, as you know, I'm terrible at drawing ellipses, more like a potato, right? Okay, so there is the sketch of this graph, right? Now, to find and solve for the foci, we need to just use this Pythagorean theorem. Now, where it might get somewhat confusing here is because they have labeled their Pythagorean theorem triangle in a different way than we're used to, right? Usually, the hypotenuse is the C and not A, okay? So when we're working this through, we have to consider the fact that it is labeled a little bit differently, okay? So there are basic formulas for the foci, and so I'm going to write those here and we will go through them. And the basic formula is the square root of a squared minus b squared. Now remember, your a squared is the larger and the b squared is the smaller. This won't ever be a negative number, okay? So looking at this one, we have the square root of 9 minus 4, right? A squared minus b squared, or the square root of 5. And they went ahead and calculated that to be 2.2, so you would go to 2.2, and you would put in a negative, of course, and you would, those are your foci, okay? So not super complicated figuring out what our foci is, all right? So let's go ahead and graph these two ellipses together and figure out the foci. We are in Algebra 2, Book 9, Lesson 7, page 21. Here is the formula for our foci. Problem number 1. For these two problems, they want us to graph the ellipse and determine and plot the foci. Problem number 1 is x squared over 9 plus y squared over 16 equals a 1. Now, because the 16 is the larger of the two denominators and it is under the y, that tells us that this is a vertical ellipse, right? So our a is equal to the square root of 16, which is 4. And our b is equal to the square root of 9, which is 3. And so we can go ahead and set up our graph. All right, so I've got 1, 2, 3, 4. 1, 2, 3, 4. So I'm at 0, negative 4, 0, positive 4. And then I 1, 2, 3 for my co-vertex. So I'm at positive 3, 0. Well, I mean, I don't need to erase the 3, but I meant to put a dot there. And 1, 2, 3, so negative 3, 0. Okay, and drawing in my potato ellipse. Looks terrible. Okay, looks a little something like that, right? Here's our ellipse. Now, figuring out our foci is going to be the square root of 16 minus 9, right? A squared minus b squared are literally just these numbers. So this time my a squared, though, right, is the 16. So 16 minus 9 is the square root of 7, okay? So square root of 7 isn't a perfect root. So let's take a look at what the square root of 7 is equal to. Square root of 7 is equal to 2.65, or basically 2.7. So plus and minus 2.7. So, but remember, we're going vertically this time, okay? So 2.7 is like right about here. And 2.7 negative is right about there, okay? You do not need to label it foci, but I do need to clearly see the point, okay, where your foci is at. If you want to label it with an F, that's fine, but you don't have to. All right, let's look at number 2. For number 2, we have x squared over 36 plus y squared over 4 equals 1. All right, so this time 36 is larger than 4, so my a squared is 36. So my a is equal to 6. My b is equal to 2, right? We take the square root of each, and now we can set up our chart. Now, because the larger number is under the x squared, this is a horizontal ellipse, okay? So I've got mine set up and marked. Since my A is 6, I'm going to go to 6, 0, and negative 6, 0. My B is 2, so I'm at 0, negative 2, and 0, positive 2. This is really squished, stretched out one here. Oh my goodness. All right, there's our little UFO ellipse. Okay, so let's now find and determine our foci. So remember, it's a squared minus b squared, so it's going to be 36 minus 4. Which is the square root of 32, which again is not a perfect root. So let's pull out our calculator, and we are going to find the square root of 32, which is, I don't know if you can see that, 5.65 or 5.7 plus or minus, remember, because we have to go both ways. So 1, 2, 3, 4, 5.7 is way over here, super close to my actual point, right? Negative 1, 2, 3, 4, 5.7 is way over here. Okay, so those are my foci. And that's it, right? Ellipses weren't hard to graph in the first place. The formula for the foci, even though they kind of mess it up and make it look weird, because, and they had to, right? Because the A and the B letters were already taken, so they couldn't, I don't know, it's just a weird setup. But this is the formula to find the foci, a squared minus b squared, the square root of those. So not a complicated step to add to our process, all right? Go ahead and finish lesson 7, meet me back here for lesson 8. Lesson 8 begins on page 23, and it's titled The Law of Sines, okay? A trigonometric equation called the law of sines makes it possible to solve triangles which do not have right angles, okay? So now we're talking about non-right triangles. The law of sines can be used to solve triangles when the following details of a triangle are known. 2 angles and any side. So for those of you who did not take geometry, that's called an angle side. Or so we have, if we knew this angle and that side, or this angle and that side. So it's kind of like, you got to think of it when they list it like this, like walking around either way of the triangle, right? You would have an angle, the next angle, and then a side. That's what AAS means. So you would have this angle and that side, or that angle and that, you know, there's many ways to do it. And then this one is called an angle side angle, which would look like this: angle side angle, if we're walking around, right? Or angle side angle, or angle side angle, right? There's multiple ways you could do it, but that's what it looked like. If we knew angle A and side B and angle C, then we could use this, okay? The other one is 2 sides and the opposite angle, which is side angle. So if you knew this side and then the very next angle, okay? Or this side and the very next angle. If you're walking around, it's always the very next thing when they have it written like this, okay? So side angle, we're walking around. Side, and this angle, okay? And this is what the law of sines actually looks like. So they've labeled all the angles, they've labeled all the sides. Notice that the angles are always paired with their opposite side. So the angles are all the capital letters, and their opposite side is a lowercase. So this is angle A, and it is opposite side A. This is angle B, it is opposite side B. This is angle C, and it is opposite side C. And so the sine of angle A over side A is equal to the sine of angle B over side B, which is equal to the sine of angle C over side C. Okay, this is the law of sines. So let's take a look at it in work. Okay, so we have an angle side that fits our needs, right? So it says solve the triangle for the measure of side A. So here's our triangle, right? We have angle, side, right? Here's an angle, we're walking around, there's the next angle, we went to the very next side, and we have that piece of data. So we have enough information. they've set up our law of sines, right? So we have the sine of 80 degrees over side A, which we don't know, which is equal to the sine of angle B, which we don't know, over side B, okay, which we don't know. And then we have the sine of 70 degrees, which is over 20, because we have that side, all right? Now, technically, we could figure out angle B because we have two angles of this triangle. And remember, all the interior angles of a triangle always add up to be 180 degrees. So technically, we could figure out B, but we'll talk about that. We'll deal with that later, okay? But what they want to know, because they don't technically want to know the angle B, they want you to solve for side A. So we need this chunk, and then we need it equal to a piece that we have all the parts of. And that only piece that we have all the parts of is our C, right? We have all the parts of that, and we're missing a part here. So we can set those equal to each other, right? So the sine of 80 degrees over A is equal to the sine of 70 degrees over 20. And then we cross multiply. We have a fraction equal to a fraction, and so we are able to cross multiply. So A times the sine of 70 degrees is going to be equal to 20 times the sine of 80 degrees. Now they just went ahead and solved for A, because that's technically what they're looking for, right? So they divide then both sides by the sine of 70 degrees. Then they went ahead and actually got the numbers. Now, with calculators these days, it isn't necessary to do all that. So let's take a look at plugging this into your calculator so you can just do it in one step. So we have 20 degrees, parentheses, right? They're there. And then the sine of 80. Now, when my calculator threw that up, it started a parenthesis there. So I need to close the 80 parenthesis. But I'm also still in this parenthesis, which I also need to close. So it's going to end up having two parentheses there. That is the correct way to put in 20 times the sine of 80. Okay, we need to close all our parentheses first, and then we can divide. Divided by, okay, and it is the sine of 70. And close that parenthesis, all right? So we do all that, we hit equals, and we get 20.96, and they rounded it up to, rounded to the nearest tenth, which caused it to round up to 21. All right, so you could solve each of these. The reason I'd rather you just plug it into your calculator directly is the fact that people have sometimes can fail to translate these numbers over correctly, and then you end up with an error. Where if you can just put it all in your calculator in one go, less chance of there being an error by a translating a number, right? Miswriting something down. Okay. So that's how we're going to do it. So it says it's sometimes necessary to calculate the third angle to have enough information to set up the equation, right? I told you here we could have calculated angle B, but we didn't need to because it wasn't what they were asking. But let's take a look at the next page to see what they're talking about. So I'm at the top of page 24, and it says angle, side, angle. So here's an angle and a side and another angle, okay? Remember, as we're walking around, we have angle A, we have side B, we have angle C. So they set up their law of sines, right? The sine of 20 degrees over side A is equal to the sine of B, which we don't have, which we can calculate, but we don't have right now, over 12, which is equal to the sine of 40 degrees over C. Now, they want us to solve for the measure of side C, but none of these fractions are complete, right? None of them have both parts, so we don't have anything to go off of. We need to complete one of these proportions so that we can do this. And to complete one, the only one that's completable, because we can't really calculate the sides with the other sides, but we can calculate the measure or the measure of this angle based on the fact that we have two of the other angles. So what did I say about a triangle? All of its angles equal 180 degrees. So if you take 180 and subtract the two angles that we already have, you'll see that angle B is actually equal to 120 degrees. So now we have a complete ratio there and a complete ratio here, so we can set up our permutation, okay? And so it's the sine of 120 over 12 equal to the sine of 40 over C that we are going to use to solve, all right? And again, they divided by 120 on both sides, and I'll show you it one more time, how we're going to put this into our calculator. So we have, hopefully you can see here, not too much glare, we have 12, and I'm going to put the parenthesis in. Here we go, something like that, okay? And then it's the sine of 40, close both sets of parentheses, okay? I need to close, oh my gosh, light. I need to close the parenthesis that came with my sine and close the parenthesis that I put in here between the 12 and the sine, okay? Divided by the sine of 120, okay? Closing that parenthesis, equal 8.906, 8.9 they want to the nearest tenth, so it's 8.9, okay? The biggest error that you might come across when you're doing the math on the calculator is not closing those parentheses. It will cause you to have issues. So make sure you're closing off your parentheses, because that tells the computer, because that's what you're dealing with, that that is the end of that first statement, okay? Before it goes on to the other next statement, all right? So one more example here we have, and it is a side-side angle. It says when a side-side angle is given information for a triangle, it will be necessary to calculate the angle value either from a table of trigonometric values or by using the inverse sign key on your calculator. So what does that mean? Let's take a look. So we have side angle, okay? Side angle. We never, ever have angle side. No. But we can have a side angle, okay? So let's take a look. Let's fill out our law of sines. We have the sine of angle A over A, the sine of angle B over 8, the sine of 50 degrees over 9. So we have a complete ratio here. They want us to find the measure of angle B. So we're going to use these two parts and set up our proportion, okay? Now, when we cross multiply, we get 9 times the sine of B is equal to 8 times the sine of 50 degrees. Dividing both sides by 9, we get this, right? Now, the reason they're using this anti-sign thing is because what this is going to give you is a decimal, right? If you were just to do this calculation without the anti-sign, this part, it would just give you the decimal, which isn't actually the measure of angle, the measure of angle B. It's just the trigonometric value for the measure of B. And so the anti-sign, or sine to the -1, the inverse sign, not the anti-sign, but the inverse sign will give you the actual measure of the angle. So let's take a look at how to do that. So let me see if I can get this calculator set up somewhere a little bit clearer. All right, so we're starting with this part here, okay, just like we have been before. 8 times the sine of 50 degrees, closing both sets of parentheses, okay, divided by 9, all right? Now, I suppose maybe you could have set up your inverse sign sooner, but to me, that's just too many parentheses to deal with, so I'm going to do it at the end. So I'm going to hit equals. That's the decimal approximation of the trigonometric value. We have used these before with our trigonometric chart. So to figure out the actual degree value, okay, now you're going to go, my inverse sign is right underneath my sign button, so I'm going to hit shift, inverse sign, put the answer in, because then it'll put that number in there, right? Close the parentheses, and I'm going to hit equal, and I get 42.91, so 42.9 degrees, okay? So that is how we can do that. And then, because they asked for the measure of angle B, so they don't want a decimal answer because that's not the measure. It's just a trigonometric representation of that, right? So we need to be able to switch it over. And then it says the same process can be used for the entire triangle. If you want to know how they figured out these formulas, you can take a look here. We are going to go ahead and do these 3 problems together. All right, we are in Algebra 2, Book 9, Lesson 8, page 25. I wrote the law of sines up here at the top. Problem number 1, we're given that angle A is equal to 30 degrees, angle C is equal to 50 degrees, side C is 8. So I'm just going to go ahead and fill in my, my law of sines. So I've got the sine of 30 degrees over side A is equal to the sine of B over side B, because we weren't given either of those, and which is also equal to the sine of 50 degrees over 8. All right, so the instructions here are to solve the triangles. They want all of the parts. So they want the parts here that are missing. So we are missing angle B. We are missing side A, and we are missing side B. Those are the parts that we need to solve for. So to start, since I have I don't have any pieces right now of B, but I do have one piece of A, so I'm going to start with this. I'm going to start for side A. So I have the sine of 30 degrees over A is equal to the sine of 50 degrees over 8, because this one is complete, right? That ratio is complete. It has both of the parts filled in. Now we're going to cross multiply, right? So A times the sine of 50 degrees is equal to 8 times the sine of 30 degrees. And then I'm going to divide both sides by the sine of 50 degrees. So A is going to be equal to, calculator work, we have 8 times the sine of 30 degrees, close, close, divided by the sine of 50 degrees, close parentheses, equals A, and it doesn't say, but since we've been up to this point rounding to the 10th, we'll just call this 5.2. So A is 5.2. Now, we've solved both of those, and you might be wondering, well, what the heck, B, I don't have any parts of B, what do? Well, I do have enough information here with my 2 angles to figure out the measure of angle B, right? Because it's going to be 180 degrees minus 30 plus 50. Because remember, a triangle only has 180 degrees to give, no matter which way it goes, okay? So 30 and 50 is 80. So 180 minus 80 tells me that B is 100 degrees. Now that I have B solved, the measure of angle B, I can solve for side B. Now, I'm going to continue to use this one. I mean, you could use A technically, but we had to round here, and so I'd rather use the numbers that they gave us that we know are 100% solid, okay? So we have the sine of 100 degrees over side B equal to the sine of 50 degrees over over 8. Cross multiplying gives me 8 times the sine of 100 degrees equal to, oh, I did that backwards. Hold on a second. I forgot I'm trying to solve for B. So B times the sine, and I like my variables on the left-hand side. It's just how I work. We could have continued the way it was, but it was bothering me, so I couldn't. So B times the sine of 50 is going to be equal to 8 times the sine of 100 degrees, dividing both sides by the sine of 50 degrees. Now this is the, we need to make sure we are using our parentheses correctly, right? When we're doing this, so we have 8 times the sine of 100 degrees, close, close, divided by the sine of 50 close parentheses equals 10.28 or 10.3 units. They don't actually give us a unit, so the length of B is 10.3. Please, when you're doing these, clearly mark your answers that we're solving for. Clearly, all right? I don't want to have to search all over the place. Like, here's where I did my work. Here is A, and here is angle B, and here, right? But I wrote them in neatly in a place that is clearly defined, all right? Problem number 2. Let's set up our law of sines, right? We have angle B is 47 degrees, side A is 5, side B is 13. So we have the sine of A over 5 is equal to the sine of 47 degrees over B, which is 13. I was going to say, I thought I had B. And then I have the sine of C over side C. Okay, we need to solve for the whole triangle. We need all the parts that are left. So we need angle A, right? Because we don't have angle A. We need angle C, because we don't have angle C. And we need side C, because that wasn't given to us either. Those are the 3 things that we're solving for, okay? This right here is our complete ratio, right? It has all of the parts. So we're going to use that, and we'll start with the A, because we need the angle A, right? So we have the sine of A over 5 equal to the sine of 47 degrees over 13. Cross multiplying gives me 13 times the sine of A equal to 5 times the sine of 47 degrees. Dividing both sides by 13. Okay. Now, remember, we don't really want the sine of A. We want the angle A. But for now, the sine of A is 5 over sine of 47 degrees. I rewrote this twice for some reason. That's fine. Okay, so remember, we're going to find the inverse sine. So we are going to end up finding the inverse sine of this. So, but we're going to start like normal. 5 times, using my parentheses, sine of 47, close, both of those sets of parentheses, divided by 13 equals. It gives me this decimal, right? But that's what we want. So we're going to go shift sine, gives me the inverse sine of that answer, close parentheses, equals. So angle A is going to be 16.3 degrees. Okay, we're rounding to the 10th. All right, so I've got that part. Now I need part C, right? All the parts of C are missing. I don't have any of them. And like I said before, I don't normally like to use something I solved for because we always round, right? Rarely does it actually work out to be an even number, but we're going to have to use that here to solve for the measure of angle C. It's the only thing we can do. So 180 degrees minus 47 plus 16.3 gives me what? Well, 180 minus 47 plus 16.3. Okay, make sure you're closing your parentheses if you're doing it this way. Equals. So 116.7. So angle C is 116.7 degrees. Now that I have that, I can use this ratio and this ratio to set up our proportion. So I have the sine of 47 degrees over 13 equal to the sine of 116.7 degrees over side C. Cross multiply, I get C times the sine of 47 degrees equal to 13 times the sine of 116.7 degrees. I'm dividing both sides by the sine of 47 degrees. Okay, so what is my C equal to? Well, let's see here. We're going to have 13 parentheses sine of 116.7 close divided by sine of 47 degrees, close those parentheses, equals 15.879 or 15.9, right? We're going to round. So C is 15.9 units of whatever those units were or are. Okay? All right, so that's it. We've solved all of the parts we were missing of number 2. Okay, so when it says solve the triangle, we're looking for the missing parts. We marked off what we were missing, and then we did the math to figure it out. Number 3. Angle A is 27 degrees, B is 30 degrees, and side C is 12. Let's set up our law of sines, okay? So the sine of 27 degrees over side A is equal to the sine of 30 degrees over side B, which is equal to the sine of angle C over 12. Now, none of these, again, is a full ratio, right? But what are we missing? What are we trying to solve for? Well, we're trying to solve for angle C, side A, and side B. Those are the 3 parts. We're given 3 parts. These are the 3 parts that we're missing. To do that, I need to have a complete ratio that I can use. None of these are complete, but I do have 2 angle measurements, so I can find the measure of angle C, which is going to be 180 minus 27 plus 30. Okay? 180 minus parenthesis 27 plus 30, close the parenthesis, equals 123 degrees. So now I actually have a complete this, right? I'm not going to write it in there because that's not how we set it up, but this one is actually complete, and so we can use it to find the rest. So I'm going to start with the A. So I have the sine of 27 degrees divided by A is equal to the sine of 123 degrees divided by 12. Cross multiply. I get A, times the sine of 123 degrees is equal to 12 times the sine of 27 degrees. Dividing both sides by the sine of 123 degrees. A is going to be equal to, well, let's get it in our calculator here. Try to move where you can see. 12 parenthesis sine 27 close divided by sine of 123 close equals 6.49 or 6.5. So the length of A is 6.5. Now we need to find the length of B. So we have the sine of 30 degrees over B is equal to the sine of 123 degrees over 12. Cross multiplying, I get B times the sine of 123 degrees equal to 12 times the sine of 30 degrees. Dividing both sides by the sine of 123 degrees, B is going to be what? Well, let's take a look. We have 12 parentheses sine of 30 close divided by sine of 123 close those parentheses equals 7.2. 7.15. We're rounding a 1 based on a 5, so it becomes a 7.2. And we have officially solved all the parts of that triangle as well. Okay? So, law of sines. We're going to set up our law of sines with whatever parts we're missing, still having variables, right? We're going to determine which one is our one complete ratio. Sometimes we're actually going to have to solve for a part first. That's what we had to do here, right? We had 2 angles, but not this one. So we were able to solve for that angle first and then had our complete ratio. But we're going to use that complete ratio along with one of the others to set up a proportion, cross multiply, and solve. All right? Great job. Go ahead and finish the rest of lesson 8. Meet me back here for lesson 9. Lesson 9 begins on page 28, and it is titled The Exponential Growth or Decay Formula. It says here, the conditions with a constant growth or decay factor can be represented and calculated using the following exponential equation. So, the amount of decay or growth, okay, is going to be equal to the amount that you started with. This A sub 0 is your initial amount. The capital A here is the final amount. I don't know why we had to use A's, but that's okay. A sub 0 is your initial amount times, okay, the growth / decay factor. It's either growing or decaying, but that factor is the G. And that G is raised to the power of T over P, which is the time elapsed, how much time has gone by, and the period for one growth cycle. How quickly does this grow? All right. So that is the formula explained. Let's take a look at it here in example number 1. It says a certain culture begins with 600 bacteria. So we have our A sub O is 600, right? How many will be present in 8 hours? Well, 8 is my T for my time. That's my elapsed time. If the bacteria doubles, doubling is my growth or decay factor, and doubling is represented with a 2, right? Twice as much. Every 3 hours. 3 hours is the period, right? So they've labeled all the different parts that they got from their story problem. And now they're going to set it up into the equation. So A, the final amount, is going to equal 600 times 2 raised to the power of 8 over 3. Okay? Now, raising it to the power of 8 over 3 is something we're just going to have to do. The powers here are going to be odd, usually. And so it's just something we have to do on a calculator. So let's look at that, okay? I'm going to do the power part first, and then we'll multiply by 600. So we have 2. My calculator has this little x to, like, it looks like an empty space, right? And that's the power of it. Makes this little caret. Sometimes that little caret, that little upside down V, is what your button looks like. Depends on your calculator. And it's 8 over 3, so 8 divided by 3 is what represented there. Make sure you close that parentheses. We've talked about how important that is, right? Make sure you close that parentheses. So 2 to the 8/3 power, if you hit equal, is 6.34, blah, blah, blah. And then we're going to multiply that by 600. And we get 3,809.76. And apparently they don't want like part of a bacteria. So it's just 3,809 bacteria, full bacteria. Okay. And so that's using the calculator. We'll do some more of that in a bit. Let's keep looking at these examples. Okay. It says a common decay factor is a half-life. The half-life of a radioactive substance refers to the amount of time it takes for half of its atoms to change into another isotope or another element. In medicine, the half-life of a drug is the time it takes for only half of the dose to remain in your bloodstream, in your blood plasma. Now, perhaps you've talked about some of this in your science classes you've done. So maybe this is review, but that is what those terms represent. So example 2. The half-life of carbon-14 is 5,732 years. So half-life already tells me my growth rate, or my decay, right, is 1/2. My period is 5,730 years. That's how long it takes for one growth rate to happen, or decay rate. If starting with 250 grams, so there's my A sub O, how much will be left after 10,000 years? That's my time, okay? That's a lot of years. But our period was a lot of years, right? So how much is going to be left after 10,000 years? So setting up our formula, our A sub O times our growth rate, which is raised to the power of 10,000 divided by 5,730. Again, straight up calculator, right? You should not be calculating this stuff on your own. So we have, this time I'm going to start with a parenthesis because In the first one, we had a 2, so that was whatever. But here I'm dealing with a 1/2. And even if you put in 0.5, which is what I'm going to do, I still like to have it kind of enclosed. So I have 1/2 raised to the power of 10,000. Make sure you're putting in all the digits. Divided by 5,730. Close those parentheses. Equals this crazy small decimal, right? But times 250. Equals. So 74.6, 74.6. I guess this time it's okay to have a partial gram, right? I guess we can't have partial bacteria, but we can have partial grams. So we started with 250 grams. So we are going to have grams left over, and it's 74.6 grams. Make sure you are using your units of measure. Okay. Example 3. The half-life, all right, so we already know our growth or decay rate is 1/2, right? Of plutonium. Then none of that matters what this actually is. Plutonium 241, whatever. None of that. That part doesn't actually matter. But it's 14 years. That's our period, right? 14.4. If an amount of 200 grams remains, so now we don't have our starting point, but we have our final amount. Our regular A is 200 grams. After 5 years, 5 years is our time that's passed, how much was there at the beginning? How much did we start with? Well, this time we're setting it up a little bit different, right? I wish they had written it in here, but we're going to just change it right there to 200, right? So 200, because that's our final amount, is equal to our A sub O times 1/2 raised to the 5 divided by 14.4 power. Okay, so then they calculated the 1/2 raised to the power as 0.786. Then you have to divide both sides by that. Okay. You could have divided here, but that's, you know, it's going to look a little messy, right? So it basically, to solve for A sub O would be 1/2, or 200, sorry, divided by 1/2 to the 5 over 114.4 power, right? So you could do that on your calculator. Let's do it on our calculator. Let's see what that would look like in our calculators here. And get to a place where we can see the work and what we're doing. So it's going to be 200 divided by, now here's where we're using our parentheses, right? I'm going to parenthesize the whole thing and then have parentheses inside as well. So maybe it's easier for you just to do it like this, but we're parenthesizing every part. So I have, so 2 parentheses now, 0.5, closing that parenthesis. The 0.5, the 1/2 is inside its own little bubble. Raised to the power of, that already starts a parenthesis, which is great. 5 divided by 14.4. I'm going to close that parenthesis. That was for my power, but then I also need to close the parenthesis that I started, right? This one out here. And then you can hit equals 254.42. Now, they rounded up to 0.5 because they had to round this first, right? They rounded too soon. So technically they're off by 1 gram or 1/10 of a gram, but that's okay. That's okay. We won't fault them too much. All right. So 254.5 grams of plutonium was what they started with. All right. So this one we kind of used, not backwards, but we were given a bit different bit of information. All right. So I'm going to get a scratch paper because it's a story problem. I'm just going to do it right here on scratch paper so I don't have to rewrite the whole story problem. So give me one moment. So for problem number 1, it just says find the answers. A culture contains 450 bacteria. Okay. My A sub O is equal to 450. All right. If the bacteria doubles, so my G is a 2, every 3 hours, my period then is a 3. How many will be present in 8 hours? So my time is equal to 8. Okay. So my formula is A is equal to A sub O times G raised to the power of T over P, right? That's the basic formula. So my A is going to be equal to 450 times G raised to the power of 8 over 3, or T over P. So there we go. That's the equation that I have set up. grabbing my calculator. I'm going to have 2 raised to the power of 8 divided by 3, and close those parentheses, equals, and then multiply that by 450, and that equals, I'm going to have 2,857 bacteria, right? We don't want to talk about partial ones. When we're talking, we want whole bacteria. 2,857 bacteria in 8 hours. That's how many there will be. Okay. Number 2. The half-life, okay, so I already know my G is 1/2 of Americium. That's interesting. 234, that doesn't matter. Nobody cares. Is 7,380 years. So the period is equal to 7,380 years. That's not true, though, about caring. I'm sure there are scientists who care. But for this class, that doesn't really matter. If beginning with an amount of 100 pounds, so our A sub O is equal to 100 pounds, okay, how much will be left after 100 years? My time is 100, okay? Rounded to the nearest pound. All right, round to the nearest pound. Follow our instructions. Okay, so let's set up our formula. So my A is going to be equal to my A sub O, which is 100, times my G, which is 1/2, raised to the power of T, or 100, over 7,380. Sheesh. Okay. It's not going to be very much less, because we're not really giving it time, right? Its period is 7,000 years, but we're only waiting 100. So I can't imagine there's going to be too much decay. But let's take a look on our calculator. So we have, since we're doing 1/2 raised to a power, again, I am going to start with parentheses. So 0.5 in parentheses raised to the power of 100 divided by 7,380, close those parentheses, equals, and then we're going to multiply that by 100, and we get what is going to be left will be 99 pounds, right? Because they want us to round to nearest pound. It's 99.06. It would have just been 99 anyway. 99 pounds. So after 100 years, you're only going to lose 1 pound of this Americium. Whatever, 243. Okay? Whatever that is. And that's problem number 2. All right, let's take a look at number 3. 1.6 milligrams of a drug remains. Okay, so this is my A this time. 1.6 milligrams. My final is what they're giving us. In the bloodstream, 8 hours after administration. So my time has been 8 hours. If the half-life, okay, so my G is 1/2, of the drug is 25 hours. So my period is 25 hours. How much was the initial dosage? Round to the nearest milligram. How much did they originally give this person? Well, let's set it up. So 1.6 is going to be equal to A sub O, because that's what we don't know right now, times 1/2 of, or sorry, raised to the 8 over 25 power. Now, if we're solving for A sub O, it's going to be 1.6 divided by 1/2 raised to the 8 over 25 power. I'm writing it like that because we're doing it all at once. We're just going to get it all in there at once. Where's the best place for this calculator here? Let's try this spot. Okay, so we have, and remember, I'm going to put the denominator in a full set of parentheses. So I have 1.6 divided by full parenthesis, right? Then a parenthesis for my 0.5 raised to the power of 8 divided by 25. Close those parentheses. And then I need to close the whole parenthesis. I need to close this one, right? Equals. So my A sub O is, and it said milligram, round to the nearest milligram. So the nearest milligram is 2, even though technically you would think you'd want 1 decimal, but 2 milligrams. Okay. 1.99 rounded to the nearest milligram is 2. So they are originally given 2 milligrams of whatever this drug is. They don't tell us here because it doesn't matter. All right, so this is the formula. We're just plugging in the information they gave us, okay? Use your calculator because, I mean, 1/2 to the 100 over 7,380 power, that's crazy. But when you're using your calculator, please use the parentheses. I feel like you probably can't overuse them, but not closing one off can mess up your whole calculation. All right, so be careful when you're using your parentheses. They are very useful and will help you get the proper answer, right? Otherwise, we're just plugging in the information they gave us into the equation for lesson 9. So that's it for lesson 9. Go ahead and finish the rest of the review. Lesson 10 is the quiz. As always, if you have any questions or need help with anything, do not hesitate to contact me. Otherwise, until next time.